Let's discuss agents. Harrison Chase, the CEO and founder of LangChain, recently spoke at a Sequoia event. His presentation covered agents, their current status, and future expectations. He discussed the environments where agents excel and where they fall short. Let's view his talk together, and I will provide commentary as we proceed. For those unfamiliar with Harrison Chase, he is the co-founder and CEO of LangChain, as I mentioned earlier. If you haven't heard of LangChain, let me briefly explain what they specialize in. LangChain is a highly popular coding framework that makes it incredibly easy to integrate various AI tools. The chain aspect was about linking these tools before the term agents became common. Naturally, Harrison Chase is extremely knowledgeable about agents. Now, let's proceed to watch the video.
Thanks for the intro and thanks for having me. Excited to be here. So today I want to talk about agents. So LangChain's a developer framework for building all types of LLM applications, but one of the most common ones that we see being built are agents. And we've heard a lot about agents from a variety of speakers before, so I'm not gonna go into too much of a deep kind of like overview, but at a high level, it's using a language model to interact with the external world.
I actually want to pause right here. Something I've often heard, though less so now that agents have become mainstream, is that agents are merely complex prompts. This isn't entirely accurate, and even if it were, the surrounding complexities are what make them unique. This graph is excellent for understanding what's happening with agents. Think of the large language model as just this small piece right here, the agent itself. And you can equip that agent with tools. They can access your calendar, use a calculator, browse the web, and even function as a code interpreter, which allows them to set up environments, write, and execute code. Essentially, the variety of tools you can provide agents with is limitless. Additionally, we give agents both short-term and long-term memory. Short-term memory refers to retaining information within a conversation or between interactions with agents, while long-term memory involves structures like RAG retrieval augmented generation. For example, retrieval augmented generation RAG involves saving information for later use. Crew AI, my favorite agent framework, has recently introduced both short-term and long-term memory capabilities, which have notably enhanced agent performance. Additionally, agents can engage in planning, which includes reflection, self-critique, forming unique chains of thoughts, and decomposing sub-goals. They can also execute actions based on these plans. With all these additional capabilities, agents, or what might simply be thought of as large language model prompts, become much more than just that. We'll delve into planning shortly because Harrison Chase makes some particularly interesting points about it. Let's continue watching. And
in a variety of forms. And so tool usage, memory, planning, taking actions is kind of the high level gist. And the simple form of this, you can maybe think of as just running an LLM in a for loop. So you ask the LLM what to do, you then go execute that, and then you ask it what to do again, and then you keep on doing that until it decides it's done. So today I want to talk about some of the areas that I'm really excited about, that we see developers spending a lot of time in, and really taking this idea of an agent and making it something that's production ready and real world and really, you know, the future of agents, as the title suggests. So there's three main things that I want to talk about, and we've actually touched on all of these in some capacity already. So I think it's a great roundup. So planning, the user experience, and memory. So for planning, Andrew covered this really nicely in his talk, but we see the basic idea here is that if you think about running the LLM in a for loop, oftentimes there's multiple steps that it needs to take.
so I'm going to pause there for a second. What we're essentially doing is enabling models to reflect, plan ahead, and break complex tasks into subtasks, which they currently can't do on their own. I've created several videos on QStar, which involves giving models the ability to plan and anticipate future events. However, that's not something we need to explore today. In fact, just today, I tested the GPT-2 chatbot, a large language model that was briefly released on LMSYS before it was taken down. Many believe this model could power agents due to its advanced planning capabilities, unlike anything we've seen before. I haven't personally observed this as I wasn't specifically testing for it. However, the key point is that agents and agent frameworks can significantly enhance the quality and performance derived from a simple large language model prompt.
And so when you're running it in a for loop, you're asking it implicitly to kind of reason and plan about what the best next step is, see the observation, and then kind of like resume from there and think about what the next best step is right after that. Right now, at the moment, language models aren't really good enough to kind of do that reliably. And so we see a lot of external papers and external prompting strategies kind of like enforcing planning in some method, whether this be planning steps explicitly upfront or reflection steps at the end to see if it's kind of like done everything correctly as it should. I think the interesting thing here, thinking about the future, is whether these types of prompting strategies and these types of like cognitive architectures continue to be things that developers are building, or whether they get built into the model APIs, as we heard Sam talk a little bit about.
Yes, that remains an open question. My guess is that it will require a completely new architecture beyond just the transformers to enable models to logically reason and plan effectively, to think deliberately and methodically. That's simply not within their capabilities today. Perhaps GPT-5 or Q-Star might be headed in that direction, but as of now, there's no large language model that demonstrates these capabilities. For the time being, developers need to construct these tools and strategies themselves, which is manageable because companies like Crew AI simplify this process significantly. Even when models eventually develop the ability to think slowly and integrate such capabilities inherently, agent frameworks will remain crucial. They provide invaluable support in coordinating various models and agents, equipping them with tools, and establishing a consistent workflow.
And so for all three of these, to be clear, like I don't have answers and I just have questions. And so one of my questions here is, are these planning, prompting things short-term hacks or long-term necessary components?
Actually, I'd love to hear your thoughts in the comments. Do you think techniques like prompting, reflection, and the tree of thoughts are just short-term hacks, and eventually models will be able to perform these tasks inherently without specific prompts or external techniques? Or do you believe these are strategies we'll need to employ indefinitely?
Um, another kind of like aspect of this is just the importance of basically flow engineering. And so this term I heard come out of this paper, alpha codium, it basically achieves state-of-the-art kind of like coding performance, not necessarily through better models or better prompting strategies, but through better flow engineering. So explicitly designing this kind of like graph or state machine type thing. And I think one way to think about this is you're actually offloading the planning of what to do to the human engineers who are doing that at the beginning. And so you're relying on that as a little bit of a crutch.
All right, that's a really good point, and it's precisely why I'm so bullish on agent frameworks. They move beyond mere prompt engineering to what we can call flow engineering, which is an entirely different art and science. We're still in the early days trying to figure out the best types of flows, how many agents can effectively work together, if there's a maximum or minimum number, and how they should plan and execute steps. It's still early, but it's really exciting to watch how this develops.
The next thing that I want to talk about is the UX of a lot of agent applications. This is actually one area I'm really excited about. I don't think we've kind of nailed the right way to interact with these agent applications. I think human in the loop is kind of still necessary because they're not super reliable.
And I want to talk about the concept of human in the loop. I work with large companies to help them develop their AI strategies where consistency, reliability, and quality are paramount. When dealing with large language models, encountering hallucinations is almost inevitable. There are several strategies to mitigate this issue. Agent frameworks can significantly reduce hallucinations by employing techniques such as caching, using prompt libraries, and reducing the model's temperature. However, incorporating human oversight or human in the loop is particularly crucial, especially for large enterprise companies. This approach ensures that outputs are checked and validated by humans, adding an essential layer of reliability and accuracy. I believe that human involvement in AI processes, often referred to as human in the loop, is unlikely to disappear soon. Harrison Chase points out that excessive human intervention can undermine the very essence of automation. There's a delicate balance in determining the necessary level of human involvement. It seems crucial, especially when the output from AI systems is significant and serves as a deliverable that the organization will rely on. Currently, I am exploring what the most effective strategy for human in the loop might be, aiming to optimize this balance.
But if it's in the loop too much, then it's not actually doing that much useful thing. So there's kind of like a weird balance there. One UX thing that I really like from Devin, which came out a week, 2 weeks ago.
Despite the criticisms and skepticism around Devon, pointing out that it might have underperformed compared to its demo, the user experience UX was widely acclaimed. Shortly after Devon's introduction, similar products like Deveka and OpenDevon emerged, suggesting that Devon did something right. The integration of various elements like the browser, chat window, terminal, and code, all within a single screen, proved to be a highly effective UI design. This approach was quickly adopted by others, highlighting Devon's significant impact. The demonstration was a pivotal moment, showing a powerful way to structure user interfaces that many found appealing and practical.
And Jordan B kind of like put this nicely on Twitter, is the presence of like a rewind and edit ability. So you can basically go back to a point in time where the or where the agent was, and then edit what it did or edit the state that it's in so that it can make a more informed decision. And I think this is a really, really powerful UX that we're really excited about at LangChain and exploring this more. And I think this brings a little bit more reliability, but at the same time, kind of like steering ability to the agents.
The feature to rewind and modify actions is indeed a remarkable aspect of user experience, especially when navigating complex tasks where directions might need adjustments. This capability allows users to backtrack to a previous state and revise their approach, which is invaluable in project management and development. But Pythagora, the AI coding assistant I've shown you, excels in this, enabling users to rewind to any point in a project's timeline to edit and continue from there. This functionality, also found in products like Devon and discussed by Harrison Chase, is a potent tool for agent coordination. It's an exciting prospect that such features might become standard across various agent frameworks, enhancing flexibility and efficiency in managing projects.
And speaking of kind of like steering ability, the last thing I want to talk about is the memory of agents. And so Mike at Zapier showed this off a little bit earlier, where he was basically interacting with the bot and kind of like teaching it what to do and correcting it. And so this is an example where I'm teaching in a chat setting an AI to kind of like write a tweet in a specific style. And so you can see that I'm just correcting it in natural language to get to a style that I want. I then hit thumbs up. The next time I go back to this application, it remembers the style that I want, but I can keep on editing it. I can keep on making it a little more differentiated. And then when I go back a third time, it remembers all of that. And so this I would kind of classify as kind of like procedural memory. So it's remembering the correct way to do something. I think another really important aspect is basically personalized memory. So remembering facts about a human that you might not necessarily use to do something more correctly, but you might use to make the experience kind of like more personalized. So this is an example kind of like journaling app that we're building and playing around with for exploring memory. And you can see that I mentioned that I went to a cooking class and it remembers that I like Italian food. And so I think bringing in these kind of like personalized aspects, whether it be procedural or kind of like these personalized facts, will be really important for the next generation of agents. That's all I have. Thanks for having me, and excited to chat about all of this if anyone wants to chat about this after.
So, this involves both long-term and short-term memory. In the short term, you should be able to interact back and forth with an agent or let agents interact among themselves where they can learn and enhance their capabilities over time. This is also a point where human intervention can be valuable as it allows for guidance and steering. Additionally, long-term memory plays a crucial role, especially in terms of personalization. Additionally, within the context of businesses and enterprises, the capability of these agents to not only access the company's knowledge instantly, but also learn and retain this information for future use is extremely valuable. This powerful feature, which is either being incorporated or is already present in many agent frameworks, is something that excites me greatly. Now, this involves a great deal of complexity. Questions arise such as how much to store, how to set rules for forgetting certain information, or whether to forget anything at all. Additionally, as businesses constantly evolve, so must the memory adapt to meet the changing needs of the business. All of this is still in the early stages. It's quite raw and underdeveloped. Now, with the ability to integrate both long-term and short-term memory, and by using flow engineering and various tools, this is certainly possible. However, there isn't yet a tried and true path. People are still exploring to determine the best or optimal combinations of these elements. We've discussed long-term memory, short-term memory, tools, the number of agents, and whether to use different large language models within the same workflow. There are so many intriguing questions that remain unanswered. And that's it. That's the whole talk. This was a great discussion. Let me know your thoughts in the comments. If you enjoyed this video, please consider giving it a like and subscribing. I'll see you in the next one.